Today we're going to look at the discriminant. Now the discriminant is something we can use with quadratics, and it helps us identify how many x-intercepts that the quadratic would have. So as we've been finding x-intercepts, we've seen that some quadratics have one intercept, they have two intercepts, or we've even seen where they have no intercepts. So the discriminant is something that we can use to identify that right off the bat. So a couple things. So here tells us what it's used for, tells us how many x-intercepts it has. Another key is remember that the word solutions can also be interchanged with the word x-intercepts. Because remember, we're taking that quadratic and we're setting it equal to 0. So we're solving for that x value that makes the quadratic equal 0. So that's why it gets that name solution. And then another big important factor is we want to make sure that our quadratic is in standard form. It's the most important part that it's in standard form, because what we want to know is we want to know the coefficients A, B, and C. We have to know what those values are in order to use the discriminant formula. So what is the discriminant formula? The discriminant formula is the value of b squared minus 4 times the value of a times the value of c. So these values of b, a, and c are coming directly from our standard form. So we're going to take these values and we're going to substitute them in to this formula. All right, so let's go ahead and take a look at how we would do that. Determine how many x-intercepts, or solutions, the quadratic has. All right, so here's our first example. I'm going to zoom out. Oh, actually, I don't have to. 6x squared minus 7x plus 1 equals 0. All right, so I'm happy it's in standard form. If it wasn't, I would want to move some terms over so it's equal to 0. I need to identify A, B, and C. So A is 6. B is negative 7. Don't forget that minus 7x includes the negative. So negative 7 for B, and then C is going to be 1. And then I'm going to take my discriminant formula. B squared minus 4AC. Now it's important that we square all of B. So if B is negative, we're going to do the negative times a negative. So the value we get for this part of the formula should always be a positive value. All right, so I have negative 7 for B. So negative 7 is going to go in parentheses. This has to go in parentheses if you're using it on a calculator, or you have to do it in your head. But you have to make sure you avoid that negative final answer. Subtract 4 times the value of A, which is 6, times the value of C, which is 1. This becomes 49. Subtract 4 times 6 times 1 is 24. 49 minus 24 equals 25. If we get a positive answer, that means there are 2 solutions, or x-intercepts. 2 solutions. So this will have 2 x-intercepts. Oh. And the discriminant was 25. All right, let's look at B. Same thing. I'm in standard form. A equals negative 9, B equals 6, and C equals negative 1. All right. B squared minus 4 times A times C. B squared, so that's going to be 6 squared minus 4 times negative 9 for A and negative 1 for C. So this gives us 36 minus, now we have to be careful here, we're subtracting 4 times negative 9, which is negative 36, and then we times it by another -1, which makes it a positive 36. So we're subtracting 36. This will equal 0. When we equal 0, that means there is one solution. So the discriminant is 0. Our answer would be one solution. And example 3. A equals 4, B equals 9, and C equals 7. So we need B squared minus 4 times A, which is 4, times C, which is 7. So we have 9 squared, 81, minus 4 times 4 is 16, and 16 times 7 is 112. All right, then we're going to subtract that. Now, think about this. 81 minus 112 is going to be a negative number, and that's the key here, right? So the reason that's key is when we have a negative number, so negative 31, that means there are no real solutions. So we have no solutions there. That means there's no x-intercepts for that quadratic. So as a recap, if the discriminant is positive, there are two solutions. If the discriminant is negative, there are no solutions. Should write none. And if it is 0, that means there's one x-intercept. And that's how we can use the discriminant to determine how many x-intercepts a quadratic has.